Hello and welcome to another episode of the Williams Learning Lab. In this episode, we are discussing chemical reactions, and by the end of this lesson, you should understand conservation of mass as it relates to chemistry, chemical equations and how to read them, and balancing chemical reactions. Let's get started. So, mass is conserved in chemical reactions. And this is because of the law of conservation of mass. The total mass before and after a chemical change remains the same. Now, there might be some cases where it doesn't appear to be so, such as when you're burning wood. So after burning 10 kilograms of wood, 500 grams of ash remained. Where did the mass of 9.5 kilograms go? Well, the answer to that is it was in the form of smoke, gas, water vapor that just left that particular location and went into the environment. Now, how to read chemical reactions, or the chemical equation rather. All right, so here what we see is we have CH4, that's methane, plus O2, oxygen, will react to form carbon dioxide, CO2, plus H2O, that's water. Okay, the left side of the equation, hopefully you know that these are the reactants. The purple arrow is the reaction arrow, and that stands for yields. And on this side, we have the products. So chemical equations sometimes include the states of matter. And so in this balanced chemical equation, we have 2H2, that's hydrogen gas, plus O2 in the form of a gas, yields 2H2O, which is a liquid. And sometimes this is important because if you have a reaction where one of the products, two liquids react and they form one solid, it might precipitate out of the solution. And you could prepare yourself to know that's something you might have to filter or keep track of it one way or another. And so it is written as, in parentheses, lowercase letters, G stands for gas, the cursive L stands for liquid, and S stands for solid. Now let's determine if a chemical reaction is balanced or unbalanced. And we'll know if a reaction is balanced if both sides of the equation, there's the same number of each atom, okay? Because we can't just destroy or get rid or lose any atoms. What I like to do is I'll put on both sides the atoms that are involved. And over here we got zinc, hydrogen, and chlorine. So I'll draw a line right here just to keep them separated. And then I have on this side 2 zincs. This coefficient of 2 says we have 2 hydrogens. And that coefficient of 2 also applies to our chlorines. So we have 2, 2, and 2. Coefficient of 2 applies to the zinc and the chlorine. So we'll put a 2 down here. And the subscript of 2 says we have 2 hydrogens. All right, since we have matching numbers on both sides, then yes, this is balanced. Okay, that's much more simple than when you have to balance them yourselves. There's a couple of tricks you can do to make it more easy. Balancing chemical equations do require practice, and the more you do, the better you'll get. So some tips that makes it easier about 90% of the time is, first, balance the metals first. Then balance the nonmetals next. Save the hydrogen and oxygen, you're going to save those for last. If you have a polyatomic ion and it is on both sides of the equation, keep them grouped together. Don't count those atoms separately. That helps out a lot. And for number 4, balance hydrogen next to last. And if there is oxygen, balance that last. Like I said, It's not perfect, but it will make it a lot easier. So here we have a chemical reaction. We got silver, we got NO3 plus magnesium, Cl2, yields silver Cl plus magnesium, and this NO3, we have 2 of those over here. So we can see immediately that it has polyatomic ions on both sides. So we're just going to track those as if they were just one atom. And so what I do for this also, I'm going to put the different elements listed over here. So we have our silver, NO3. I'm going to keep that group together. We have magnesium, and we have our chlorine. And then I'm going to write the same thing on this side of the arrow. Okay, we draw a line. First thing I'm going to do is just count them, see how many we have. Okay, we have 1 silver. The NO3s, we have 1 of those groups. Mg, we have 1. Cl2, we have 2 of those. Okay, Ag, got 1. Our NO3, well, since it's covered in parentheses and has a subscript of 2, that means we have 2 of those groups. That's immediately unbalanced, so we're going to have to worry about that in a moment. And for our magnesium, we have 1. And our chlorine, we have 1. Well, according to our tips, we're going to balance our metals first. Well, our silvers are balanced. They're both 1. Our magnesiums are balanced. They're both 1. Okay, so let's work with our nonmetals. On this side, we have 2. And over here, we have 1. So let's figure out what number can I multiply times 1 to get 2, right? That number's 2. So that number is going to be the coefficient that we put in front of this chemical. Now that we did that, it's going to have consequences. So now we'll have 2 silvers. Okay, now we'll have 2 chlorines. And this did not affect the other product that we have. So that just remains 2, that remains 1. Okay, the consequence of this is now we have our chlorines are balanced, but now we are out of balance with our silver and our NO3s. So let's just begin with our silvers. What number can I multiply times 1 to get 2? Well, 1 times 2 gives us 2, so we'll put a coefficient of 2 right here. Now that has consequences. Let's see what those consequences are. So if I put a coefficient of 2 here, we now have 2 silvers. We have 2 of the NO3 groups. We still have 1 magnesium, and we still have 2 chlorines. Now let's see if they match. 2 silvers on both sides, 2 NO3s on both sides, 1 magnesium on both sides, 2 chlorines on both sides. So we have now balanced this chemical equation. If you found this video helpful, would you consider commenting, or subscribing? If you have any questions about this or any other topics, please leave them down below. I'd love to hear from you. Until next time, thank you very much for watching. Have a nice day.